NASA is taking an extreme look into the mysterious regions of outer space.
Extreme!
IXPE, the Imaging X-ray Polarimetry Explorer, is investigating neutron stars, black holes, dark energy, dark matter. All words you might hear during a rigorous speed dating round sponsored by Mensa. With its finely tuned instruments peering into our solar system and beyond, phrases like polar jets of active galactic nuclei will soon be more popular than the next Buckaroo Banzai franchise. Check out IXPE and put the Geek Squad on notice.
Welcome to NASA Edge.
An inside and outside look at all things NASA.
We're in Hangar AE on the Cape Canaveral Space Force Station in Florida, and today we're talking about the IXPE mission. And what does IXPE stand for?
IXPE's great, but also Launch Services Program is launching a rocket from Pad 39A, a really cool event for IXPE.
Are you trying to dodge the question? So what's IXPE stand for?
You're going to go there, right? Okay, so
right.
It's the Imaging X-ray Polarimetry Explorer.
Great job.
Yeah.
I tell you what, this is an exciting mission. Anytime we're dealing with space and astrophysics, it's really cool because researchers and scientists are going to be looking at black holes, supernova remnants, quasars, pulsars, even the galactic center.
And I love all those cool things, but I got to tell you, Chris, I have a little bit of intellectual and academic anxiety because I feel like that kid that has the dream that there's a pop quiz or a test all of a sudden and he's not prepared. I hope that I'm up to the challenge today for this show.
Well, I tell you what, when you interview Brian Ramsey, who's the deputy principal investigator, start off with the word polarization and see where that gets you.
Okay. All right. Well, Sad, thanks for the tip. That's a good way to start the show.
I tell you what, we're just over 13 hours away from launch, and let's take a look at the pad where we see the Falcon 9, and inside is the IXPE spacecraft. But coming up, we're going to be talking to Paul Hertz, who is the Astrophysics Division Director at NASA headquarters. So, being the division director, what are the goals, NASA goals of astrophysics?
Well, we want to understand the universe. We want to understand how did the universe come to be and how has it evolved. We want to understand how the familiar night sky of galaxies, stars, and planets came to be. And we want to understand, are we alone in the universe?
And what are some of the programs do you have within astrophysics?
So we sponsor a full range of research for the U.S. science community to investigate the universe. And that's everywhere from grants to researchers at universities and research labs to do their own work with their graduate students and their postdocs, to small missions, the ones that we launch on sounding rockets, balloons, medium-sized space missions like IXPE, and the great big space missions like the Hubble Space Telescope and the James Webb Space Telescope. So it's a full program to investigate the universe.
Yeah, I was just going to ask you that because NASA Edge has covered some really cool astrophysics missions in the past, like TESS and RADX. And so you have the whole gamut when it comes to your assets. You have space base, you have air base with Sophia, and then you have, of course, ground base as well.
Yeah, it's a great job to be in charge of all of that. And the important thing to recognize is that you can't start with a Hubble Space Telescope or a James Webb Space Telescope. You've got to have the research that leads to the missions, that develops the technology. I mean, IXPE is flying X-ray mirrors that were developed at Marshall Space Flight Center over a period of years, tested on sounding rockets before they were ready to put onto a satellite like IXPE. We have to develop the techniques for analyzing that kind of data, and that's done by scientists all over the country. And then we want to have missions to investigate all parts of the universe, and that takes different kinds of observatories, right? You need the visible light observatories like the Hubble Space Telescope. You need the infrared observatories like the James Webb Space Telescope. You need X-ray observatories like the Chandra X-ray Observatory, which is our great observatory for X-rays. But if you want to measure polarization, you need a mission like IXPE.
You know, you actually lead me to my next question. You know, we've done many missions in the past dealing with X-rays. How is IXPE different than other X-ray missions in the past?
Well, that's the four-syllable word, polarization, right? So whereas a mission like Chandra takes exquisite images and also can measure the energies of the X-rays, which we translate into colors in the Chandra images, what it doesn't measure is the polarization of the light. You know, when light scatters off of surfaces, it can be polarized, where it's all vibrating in the same direction,
right,
and not random directions. You get an example of that when sunlight scatters off of a body of water, the light gets polarized, and that's why your polarized sunglasses are so effective. What IXPE can do is measure the polarization of the X-rays, and that tells us about the surfaces they scattered off of, the magnetic fields and the structure down there close to the black hole, close to the neutron star, where we can't see because it's hidden by the gas and dust and plasma that surrounds those dense objects.
And we're looking forward to seeing what's going to happen, you know, and what kind of data we're going to get back. But Paul, thank you so much for joining us today. Good luck tonight. I hope you get some rest.
Oh,
1 o'clock in the morning is going to be coming soon.
I'm bulldozing through. I'm not going to sleep. I'm going to be there bright-eyed and bushy-tailed for that launch at 1 o'clock in the morning.
All right, Paul. Hey, when we come back, Blair's going to be talking more about the IXPE mission.
Joining us now is Brian Ramsey, who's the Deputy Principal Investigator for IXPE. And I don't know if you heard earlier, Chris suggested that I ask you first about this unique word, polarization. Can you tell us about that and how it relates to IXPE?
Sure, I can. So X-rays are electromagnetic waves. They, like all electromagnetic waves, they have an electric vector. If we collect a whole lot of X-rays from a source and all those vectors are in exactly the same direction, all those fields are pointing in the same direction, we say that that radiation is 100% polarized. And if those directions of the electric field are all at random, we say it's totally unpolarized, and there's everything in between. And why that's important is because we're looking at very dramatic objects. We're looking at very, very high temperatures, matter swirling down onto black holes, or incredibly intense magnetic fields, 1,000 million times the field of the Earth. And in processes like that, the X-rays that are generated are polarized. And so by measuring polarization, we measure the degree and the angle of the polarization. We can sort of probe the mechanisms inside these really exotic sources.
And that's fascinating. And the next question I have is, when I hear that, is, well, how does it work in terms of IXPE?
Right, so we have some very special detectors on board that were contributed by our Italian partners. These detectors are what really have made IXPE possible. They have a special gas inside that absorbs the X-ray. And when they interact with the gas, they're converted into an electron. And this electron is shot out of the atom, and then it comes to rest in the gas. And that initial direction of emission of the electron is in the same direction as the electric field. So if we collect lots of these events in our detector and we measure the direction that the photoelectron is emitted, then we have a measure of the polarization of the X-rays.
It's fascinating to me. I mean, I understood some of that. I'm really trying because I'm kind of feeble in that area, but I got to tell you, it's still exciting. And I'm wondering, from NASA's standpoint, have we done any other X-ray missions that use this polarization technique?
No, this is the first mission that's sort of dedicated to polarimetry. As you heard from Paul, we have other X-ray astronomy missions that are flying now, and they do imaging and spectroscopy and timing and things like that. But this is the first mission that will have polarization capability. The interesting thing here is that the principal investigator for IXPE, so I'm the deputy, the principal investigator is Martin Weisskopf, and he actually made the first measurement of X-ray polarization from a cosmic source, the Crab Nebula, in the early 70s. And that was followed up by a satellite measurement. It was a very small polarimeter, one of a suite of instruments on a satellite, and that confirmed that measurement. And the very interesting thing is that from that day to now, there have been very few additional measurements. And so here we are 50 years later, and we're about to launch what's needed, and that's a mission dedicated to X-ray polarization.
That's fascinating, because then we have that data to compare all the IXPE data with. Looks like a lot of cool scientific things coming from IXPE. Brian, thanks so much for being on the show.
Sure, welcome.
Last week, I had a chance to learn more about the mirrors on IXPE. Let's check it out. Joining us now is lead mirror scientist Stephen Bongiorno. Stephen, thanks so much for being on the show today.
Thank you for having me.
One of the big questions I have right off the bat is about the work you do with the mirrors, because I know they're essential for the mission, but they're very complex and sensitive instruments. So what was it like to develop and build these mirrors?
It was a great challenge. We actually built 4 mirror modules for IXPE. 3 of them will fly on the observatory, and we have 1 spare.
How do you test something so complex like these mirrors in space when you really can't test unless you go there?
Well, so what we did was, after we built the mirror modules, we subjected them to what's called environmental testing, where all the relevant environments that the mirror module would experience on its way up to orbit, we tested that on the ground at Marshall Space Flight Center. So these are things like thermal testing or vibration testing, because rockets vibrate quite a bit when they launch, or shock testing, because as the observatory goes through its deployments, it deploys a long boom to set the optics at the correct focal length. There's a shock associated with that. And so the space is an interesting thermal environment. It can be very cold and it can be very hot. So we put the mirror modules through thermal testing to make sure that they'll work. And then the key is, after all of that environmental testing, we calibrate them, again, here at Marshall Space Flight Center, to make sure that they work. Calibrating means that we put them in a facility called the Straylight Test Facility. This is an X-ray beam line. It's where you have a big, long vacuum chamber. It's 100 meters long, and you put an X-ray source at one end, and you have the optic and a detector at the other end, and you take a picture of that X-ray source. And it's pretty much like a star. It's very close to how a star would look in the sky when the observatory is doing its thing on orbit. And so this helps you gain confidence, make sure that it's going to work like you expect when it's in space.
And that had to be a tense moment, waiting to see whether your mirrors had withstood all of those elements.
You have no idea. Yep. I painstakingly had my hands on every single mirror shell, and all 96 of the mirror shells that went into these 4 modules, and I glued them all in place. And I was very eager to see the results after that calibration, to make sure all was well.
That's got to be a great feeling, though, when you have gotten the results back and you feel confident like you do. Mm-hmm. I mean, that's a unique job. Tell me a little bit about what it means now that IXPE is about ready to launch.
Oh, it's so special. It's an incredible feeling to have literally touched a piece of hardware and put so much work into it, and then know that it's going to be up in space making measurements that nobody's ever made before. That's what's special about it for me.
Well, as we've learned at NASA, you can never get enough science, especially as we start to look even deeper and deeper into space. Stephen, thanks so much for being on the show.
Thank you so much for having me. It was a pleasure.
And joining us now is the project manager for IXPE, Randy Baggett. How you doing, Randy?
I'm good. Good, thank you.
Are you feeling pretty good?
Yeah, it's getting close. We're ready, I think.
So, as project manager, one of the things when we talk about all these big missions at NASA, it takes a lot of partners, and I'm sure IXPE has many partners for this mission. Can you kind of identify the major players and what their roles are?
Sure. Yeah, we're fortunate to have our international partners, who was a big contributor for IXPE because of the detectors and the instrument that was provided through Italy. That's our Italian Space Agency contributed that. So that's a very fortunate for this mission, and it enabled us to do, obviously, the science that we've heard about already. And also our partner at Ball Aerospace. Ball is responsible for actually fabricating and building the spacecraft, and also the payload. So, and integrating that and testing it. So that has been a good partnership as well. And also we have for our optics, we had the thermal shields was provided by Nagoya University over in Japan.
Oh, wow, okay.
So we had a collaboration with them.
So kind of take a step back. When you started with this mission 5 or 6 years ago, How did you how do you come up with partners, international partners for a mission like this?
Well, primarily through our PI and the team that was assembled then, we had looked at the best opportunities there that we could collaborate and allow for the best proposals. Being competitive selected, it was important to get that, of course. So, yeah, I think in that time we basically just looked at what was out there that we could collaborate with and try to get the best.
Now, when you look at a project like IXPE, there's always challenges along the way. I mean, what are some of the challenges that you face with this mission, and how did you overcome them?
Yeah, I mean, it's been quite challenging in several ways. We've had some issues, of course, with the pandemic, of course, and then that has also some things with even the government shutdown and understanding how that has affected us has been a challenge in some ways. But as far as just the technically, I think the guys have pulled together. We've kind of changed our operations with the pandemic and worked a lot from home, obviously, and of course the technicians and the guys building the hardware, they've been able to come in and we've been able to safely do that. So it's been a bit of a challenge and unique, obviously, for a mission like this.
To make a mission like IXPE successful, it really comes down to the people.
Right.
And you lead a great team of scientists, researchers, technicians. Tell me about the people of IXPE.
Yeah, I mean, that's exciting to see, how they've grown first and the opportunities that they've had. And of course, many of them, are doing things they love to do. And of course, that's an important thing for all of us.
Now, okay, Randy, we're just over 13 hours away, 1 o'clock in the morning launch. I got to ask you a serious question. Have you thought about your pregame or pre-launch meal yet?
No, I'm hoping to get that, but yeah, I hadn't really thought about it. But I'll be ready.
Well, Blair was telling me that you got to have Italian food.
Oh yeah.
But the problem is sometimes Italian food, it's heavy, right?
Yeah,
and if it sits in your stomach, you may fall asleep and miss the launch. So you
Right.
don't want to do that, though.
Right. No, I don't want to do that. So I'll be careful. Thank you.
Well, Randy,
thanks for that reminder.
Well, Randy, thank you so much for being on the show. Good luck with the launch, and
Thank you.
we can't wait to see the first sets of data that come in.
Yeah, us too.
Let's take a look at the pad right now as we see the Falcon 9. What a beautiful sight. The IXPE spacecraft is inside the fairing. But coming up next, we have Franklin Fitzgerald and Mick Woltman. And Mick's going to take us through what it takes to get a rocket like the Falcon 9 to the launch pad and ready for flight.
Good morning, Mick.
Good morning, Franklin. Glad to be here, man. Excited for launch this morning.
Absolutely. Can you give us a rundown on the Falcon 9 and IXPE right now?
Yeah, absolutely. The team last night came in. They mated the spacecraft to the Falcon 9 a couple days ago, came in early last night, got it mounted to the transport erector, transported the whole vehicle out to the pad, got it up, hooked up the umbilicals to make sure power and commodities were there, did some vehicle checkouts to make sure everything was good. Spacecraft did their communication checkouts, all was good. And the team is now preparing for an early morning launch later this evening, early tomorrow morning.
Yeah, absolutely. What is the weather looking like right now for this launch?
Yeah, weather is really good right now for launch, and we've got about a 10% possibility of violation, or actually a 90% go for launch early this morning. We do have the Space Force weather officer did tell us we have a front moving in over the next couple days, but hopefully we're going to get IXPE off early this morning on the first attempt, and we'll be good to go.
Now, a couple days ago, LCRD was delayed a little bit because of some high-level winds. Is there any chance of that happening, and how long is the window for this launch?
Yeah, so always a weather thing going on here at the Cape, but like I said, tonight or early this morning, we've got a 90% chance to go, so that's looking good. However, IXPE does have a 90-minute window today. The unique thing about the Falcon 9 rocket, though, is once we start fueling and we put densified locks on board the rocket, we have now picked a specific time in that 90-minute window, and we're going to have to launch at that time. So just prior to putting fuel on board, we can pick any moment in that 90-minute window. But once we start loading fuel at about T-minus 35 minutes, we've picked our T0 for today.
And that's one of the differences between SpaceX and, say, for instance, ULA, in the way that the rocket is fueled.
Yeah, it's absolutely a difference from other manufacturers because SpaceX uses this densified liquid oxygen to be able to get as much liquid oxygen into the rocket as they can in order to have enough fuel not only for ascent to get the mission done, in this case IXPE, but also have some fuel left over for their first stage landing, which is unique for this mission because this will be the 5th time we've used this first stage booster.
Now, the processing of the satellites and the rockets change from launch provider to launch provider, but can you tell us a little bit about how SpaceX does theirs horizontally on the ground?
Yeah, absolutely. The spacecraft comes in, usually arrived here at Kennedy for the IXPE mission. They did their processing in the payload processing facility. Then once they were encapsulated, they were rolled over to the hangar, and then SpaceX mated the spacecraft to the Falcon 9 rocket in the horizontal position. And then once that's all done, checkouts are all done. As I said earlier, they put the rocket on the transport erector. They get that ready to roll to the pad as one huge assembly. So the whole rocket, and then they lift that up on the pad to go vertical for launch. And what's unique about that is that transport erector is also what we call the strong back. You'll hear that later. That's used at launch early this morning. That strong back will come back several degrees just prior to launch, and then we'll get ready. So unique processing that SpaceX does with the Falcon 9 in that category.
Can you talk to us a little bit about the significance of using Pad 39A?
Oh yeah, we're very excited. Launch Services Program, this is our first time launching off a historic 39A. 39A was used for the Apollo program, shuttle program, and launch services. All of our scientific missions have typically gone from the Cape side here at Kennedy Space Center, but this is very important for us. We're launching off a 39A, our first scientific robotic mission. We're excited about that. The team will be in Firing Room 4, historic Firing Room 4 over at the Launch Control Center here on Kennedy Space Center. I'm jazzed about it. It's exciting to see a scientific mission go from that pad.
Now, can you talk to me a little bit about the pads that SpaceX has here between the Cape and Kennedy?
Yeah, absolutely. As we mentioned, 39A, that's where IXPE is going to be launching for later tonight, early this morning. But SpaceX also has Launch Complex 40, which is on the Cape side. And what that does for them is having the 2 pads here on the East Coast is they can alternate between the pads mission. So that cadence of launches that they have, they can keep that up by alternating between the pads. And then on the West Coast, they have Slick 4E, which we were just at a couple weeks ago for the DART mission.
Absolutely.
They have that out there on the West Coast that they can continue launching from for polar orbits and things like that. So those 3 major pads that SpaceX has allows them to keep up that cadence that they have, and it's great to see what they are doing with all the missions, not only NASA LSP missions, but some of their Starlink missions and some of their commercial partners.
From launch to launch, you are on console or doing launch commentary. What are you going to be doing this evening?
I will be doing launch commentary for the IXPE mission, calling the launch. Most importantly, the last 7 minutes down to liftoff. Be exciting to see IXPE get on its way. This, as we heard earlier in this show, exciting science that IXPE is going to be doing. Very unique, and I'm looking forward to what we get out of that.
Well, Mick, that sounds like you have a pretty interesting day and morning in front of you. We look forward to your coverage, which begins at 12:30 on NASA TV. So make sure you tune in. And for future videos and follow-up to this mission, you can check us out on NASA Edge on our website, at our YouTube channel, our Facebook, Instagram, and Twitter feeds. You're watching NASA Edge, an inside and outside look
Of all things NASA.
at all things NASA.
At all things NASA.